All right, I've gone through and tried to list out all the potential errors that I could think of and that traditionally happen in this lab. We'll discuss those before getting into the nitty gritty of the procedure. Be sure to try not to lose crystals when you decolorize. That is a very easy place for one of the errors that we often see in this lab. Make sure that you pour boiling hot solvent into the filter paper / funnel if you do happen to see crystals that are trapped there. Remember, any crystals that are trapped in that fluted filter paper will not be moving on with you, meaning they don't get counted in your final mass, so you get a really low % recovery. As I mentioned in the earlier video, you may still have carbon in your product after you decolorize. That means you need to filter again. Yes, that's a pain, but it's better to do that than have an over 100% recovery, which is technically impossible. Okay. Sometimes you may, you're learning the technique, you may actually dilute your crystals with too much solvent. You can do this at the beginning. Perhaps you are trying to recover crystals from your decolorization apparatus and you add more solvent in order to dissolve those crystals. If you have too much solvent at any stage, make sure to boil off some of your solvent prior to your final crystallization, i.e. the cooling step, okay? So make sure that you kind of do a visual check of how much volume you have in your flask at all times. If you want to grab a Sharpie so that you can mark it at the beginning, that way you can kind of make sure that you have the same volume throughout, that you haven't added too much solvent. That's not a bad idea either. If you have too much solvent, your crystals will not precipitate, or you'll get a very, very low yield because you have too much solvent and your material, yes, temperature increases solubility, but so does just adding a whole bunch of solvent. Think about your sweet tea. If you dissolve sugar when it's hot, then you can dissolve a lot of sugar in it. But also, if you just keep adding a lot more water, that sugar will eventually dissolve even at room temperature. Another error is rushing the cooling process. This lab, especially with COVID social distancing, may take longer than usual since we do have the bottleneck of the filtration apparatuses. So if you're trying to rush to get done, you may not let your solutions cool all the way at room temperature, or you may not let it chill in the ice bath long enough, and that can result in you not crashing out all of the purified crystals. The other thing that I'll tell you, a lot of these labs, if you keep everything through the end, we can go back and fix it if you make a mistake, okay? So we can go back and find your crystals or go back and, remove some impurities. We can fix it at least to some degree if you don't throw it away. But for instance, going back to that gravity filtration, if you do the gravity filtration and then immediately throw out that filter paper, we can't look at it to see if maybe there were crystals in there or not. That's why I'm telling you, keep everything until you have isolated your crystals and they are drying in your drawer, okay? If you throw stuff away or if you pour your what you think is waste out, I can't do anything to help you. The other common mistake is not recording masses and data. People forgetting to record the mass of their watch glass something's going to dry on, the mass of their filter paper. People forgetting to record the mass of the starting amount of acetanilide that they weigh out to recrystallize. Lots of small, silly little mistakes. All right, so just to recap, ultimately, we can kind of break this down into three very large major points, rather is what I should say. You're going to purify the crude acetanilide, which I'll take you through that step-by-step process for this specific lab here in a minute. After your crystals have dried, then you will calculate your % recovery and then check the purity of your recrystallized product using melting point analysis. You do not want to collect samples for melting point until after you've gotten your mass for the % recovery. All right, the first part of your procedure, you'll be choosing a recrystallization solvent. Your lab book gives you 4 potential solvents, and like I said earlier, you typically don't just check one solvent at a time. You use several solvents to compare one another, okay? So you will be testing the solubility of your acetonilide at room temperature with the solvents, and if your acetonilide is soluble at room temperature, that automatically means that that solvent is not a good choice for recrystallization. Usually that step eliminates some of your solvents, and then the 2 that it was insoluble at room temperature, you then heat those up in a sand bath, and if your acetonilide is soluble in the boiling solvent, but it wasn't soluble at room temperature, that's your recrystallization solvent for this lab, okay? We should have solvent waste containers in one of the hoods or in a couple of the hoods. And so be sure to keep up with which test tube, this is you're testing your recrystallization solvents in test tubes. Be sure to label your test tubes carefully so you can put your solvents in the correct waste containers. You can wash the test tubes and keep them in your drawers for later uses. Once you've identified a recrystallization solvent, you'll dissolve the impure acetonilide in your selected solvent. Be sure to use the right amount of solvent. Just add enough solvent until the crystals dissolve. You don't want to overshoot that at all, okay? Remember, you're heating the solvent on the hot plate so that it's basically boiling when you add it to the crystals. And once you start adding the solvent to the crystals, you don't want it to cool down. Otherwise, you're going to overshoot your solvent amount. So you want to, once you have liquid in your crystal flask, you want to kind of keep that heating as well. Remember the 5% rule that we discussed in the earlier lab. So once you've got your volume from the boiling hot liquid, then you can calculate your 5% excess that you'll add in. After you have dissolved your acetonilide, you will do the decolorization step, okay? Your lab book has this written up decently well, but after part B, which is only a line or two, really there should be a paragraph space in between that, because it's telling you to do 2 things at once that doesn't necessarily read very clearly. I've tried to clarify here on the slide. First, you're going to add the specified amount of activated carbon to the acetonilide solution and reheat that solution to boiling. While that solution is reheating and getting back up to boiling temperature, you are going to go through the process of heating the gravity filtration apparatus, okay? What that means is you're going to be boiling some recrystallization solvent, and you will have that boiling solvent and pour that through the gravity filtration apparatus. That will wet the fluted filter paper and get the glassware hot enough so that hopefully when you very quickly afterwards pour your acetonilide solution with the carbon in it through the gravity filtration apparatus, you will not have any crystals form. The one thing to remember, once you heat up the glassware with that boiling hot solvent, you want to get a new 100 milliliter beaker to put underneath the gravity filtration, okay? They describe it a couple different ways, but you do not want to empty your acetonilide solution and filter it into the beaker that contains the boiling solvent from the heating part, okay? So basically, you're heating your acetonilide solution with the activated carbon, and you're heating boiling solvent to warm up the glassware at the same time. You will take the boiling solvent, pour it through the gravity filtration, change out the collection flask, and then very quickly pour the boiling hot acetonilide activated carbon solution through it, okay? So the part that you're doing together, parts A and B in your lab book, are the heating of the solutions and getting that glassware ready for the filtration, okay? Make sure to, like we've said, make good observations. If you do have crystals that form, record that. Make sure to look inside that filter to see, is it just activated carbon, or does it look like there's perhaps some crystals of acetonilide that formed in there because it didn't filter fast enough, or the glassware cooled off before you were able to do the gravity filtration.